Alright, so now we're going to be talking a little bit about frequency tables. To make an accurate picture of data, the first thing we want to do is make piles. For categorical data, piles is pretty easy for us to do. We just count the number of cases corresponding to each of the categories. We can organize these counts into a frequency table. Which records the totals and the category names. Frequency tables are often used to organize data. You've likely been making frequency tables since like grade 4 math when you were asked what your favorite sport was or if you liked vanilla or chocolate ice cream. But the example we're going to do today is that grade 12s were asked when their spares were, and then we got this huge stack of different results. If you look at just this information, and I gave this to whoever was asking for that data, that doesn't really tell me that much helpful understanding. Like, yeah, I can see there's a whole bunch of students, there's some A's, B's, and C's, but I might need a little bit more information. Maybe depending on your school, like A, B, C, and D corresponds to period 1, period 2, period 3, and period 4 spares. That might be helpful just to have the language make sense for you and your school. We want to organize this data into some sort of a frequency table. Then we can see what we're going to call the distribution of the data. So how is it distributed students between A, B, C, and D, and compare them to each other. So what we're going to do in our spare, we're going to put our categories A, B, C, and D. That's why it's categorical. Those are the 4 categories of answers. Frequency is just going to be the number of, in this case, A's. So I'm going to go through this big data set here. I'm going to count up all my A's. I encourage you to pause this and do it on your own. Make sure that we are comfortable with building a frequency table. But we're going to get the values of A to be 15. We're going to get the value of B to be 14. I might be going through and crossing these off one at a time to make sure that I'm counting them correctly. 9 and 12. So even right away there, we can see that it's a little bit more helpful. You see most students have, or the most common one is period 1 or period A, followed closely by B, followed closely again by D, and the fewest number have C. So counting the frequency is a useful thing to see, but sometimes we want to see the proportion of the data in each of the categories. The proportion means that we're looking at how much of the total amount of data shows up in each one of the categories. So we're going to make something called a relative frequency table. The cool thing about a relative frequency table is that it shows the data as a fraction or a percentage. Of the whole data set. So the first thing that we need to do to change this is we need to know how many actual people were surveyed in this data set. So I can go back and I can sum all of these up. So if I went and I did 15 plus 14 plus 9 plus 12, I know that we surveyed 50 students. That's going to be helpful in a moment. These first two here are going to include all the information we previously covered. So I just copy that down. A, B, C, and D. 15, 14, 9, and 12. Now for a relative frequency, we're looking at it as a fraction of each category over the whole data set. So if we're thinking about this fraction, I'm going to have the frequency of the category over the entire data set. That's going to give me the fraction to use. So if I build it for this first one, I know my whole data set is 50 students. And then the frequency for spare A is 15. If I want to write that out as a percentage, because remember, we write it as fractions or percentages, I can fill that out by going the numerator divided by the denominator and multiply it by 100. So I would get, 0.3, and then I'd multiply that by 100%, and I would get 30% of students have a first period spare or a period A spare. I can continue that process. I'd get 28%, I'd get 18%, and I'd get 24%. Things that we want to keep in mind, we already know these add up to give me 50. When I sum, let's move that up a little bit. When I sum that, if I add all these together, I need to get 100% because that takes care of all the students in the entire data set. And we can see right away that we are much more comfortable talking about proportions of data and analyzing that distribution than we are just seeing the numbers. Like, I know these are close together, but the idea of 30% and 28% being close together makes a lot more sense for me to analyze.